Hey, hi. In this video, I'm going to show you how to deploy Azure AKS cluster with using Terraform Cloud and GitHub Actions. As you see in this PPT depicts my demo here. So here I'm going to walk you through like how we can create an AKS cluster with using Terraform as infrastructure as a code, where we're going to use the Terraform Cloud to store the state of the infrastructure or state of the Azure AKS service. And then here we're going to use the GitHub Actions to do the CI/CD of the workflow. In the sense, we use GitHub Actions to deploy the EKS cluster. Plus, we use GitHub Action also to deploy an example application on Azure Kubernetes service. Okay, so the flow of this demo is something like this. So here you have a developer who is working with the version control tool like GitHub, where we're going to write the multiple Terraform file which is required to spin up the Azure Kubernetes service. And then we also configure the Terraform cloud as a remote state storage. So in that case, the execution of these Terraform file will happen from the Terraform cloud. And we will also have a task in the GitHub Actions or CI/CD pipeline where we will deploy an example application on this Azure Kubernetes service on the go itself. In the sense, in the first part we create a cluster, in the second part we deploy our application directly on the Kubernetes service, and finally we will see that the application is accessible, something like this. All right. So in total, the flow is from the GitHub Action, GitHub and GitHub Action as a version control and CI/CD tool respectively. We will use Terraform Cloud to store the Terraform state file, and then finally we will see that underneath the Azure subscription we will have a Kubernetes cluster up and running fine. And then on that Kubernetes cluster we also deploy an example application, that is some store application, and that will be accessible in the internet. Okay, that is the main aim of this demo. Okay, all right. So with that note, what I do is I'm going to walk you through the first code, so which I have in the GitHub repository already. So first let me take you to my GitHub repository. So this is my GitHub repository. Yeah, so this is, as you see here, so this is the GitHub repository where the code required to spin off the Azure AKS cluster is being configured here. In the sense, I have a folder called AKS. In that one I have created multiple .terraform file, and then we also have .github /workflow files as well, which actually defines the CI/CD pipeline of the with using the GitHub Actions. Okay, and also underneath the AKS we also have another file called AKS apps, where we have kept the manifest file or specification file to deploy an application on Azure AKS. Right. So what I do is I'm going to walk you through this complete folder quickly, and then we're going to see that how did I define the workflow file as well. And then finally I'm going to take you to my Azure subscription, showing that the cluster is up and running fine. And then finally I'm going to show you my Terraform the cloud as well. So this is my Terraform cloud subscription. How did I set up the the Terraform cloud workspace, and what are the configurations I did there. So I'm going to show you like step by step. Okay, so have a patience and watch the videos from end to end. Right. So what I do is I'm going to take you to the first the what did I do in the Terraform file, which declares my the state of the Azure AKS cluster. So here I have I will let me minimize this AKS app, which is actually a manifest file only. Then the rest in the underneath the root folder of AKS we have the all these .tf are nothing but the tf file which is actually constructing the Azure AKS cluster. So here in this min.tf we will have some random pet resources. You see I'm creating a random pet resource for some RG name, in the sense generating the resource group name dynamically. Yeah, and then we have I'm just using this the random pet name, and then we are using the RG name to create a resource group. So this is the a resource definition which will create a Azure resource group in the Azure subscription. And then we have the I'm also using the another random pet in nothing but it generates a random name. Okay, so that is used for Kubernetes cluster name. And we also generating the another random pet name for Kubernetes cluster DNS prefix purpose. Okay, so here it uses cluster prefix, and then it dynamically generates a random pet name which will be suffixed after this one. Okay, so basically that these random strings are used to construct the AKS cluster name plus Kubernetes cluster DNS prefixes. Okay, and then we have a very last resource that is actually creates a Azure Kubernetes cluster. So the resource type is Azure RM underscore Kubernetes underscore cluster. You can find more details about this resource type in from the the Terraform registries. So here we have this is a resource, this is the the resource type, and we have a resource variable name, and then we have in the for bracket we are giving the required parameters of this resource, that is Kubernetes cluster, which is our main original resource of this demo. So here I'm using the location which is being fed from the the resource group location itself. So if I go to the resource group location, so the resource group locations are being used from the variable file. I'm going to walk you through that as well. Then we have a name, so this is the name of the cluster which has been generated from the random pet. Then we have a resource group name being referenced from the above. Then we have a DNS prefix also being used here. I'm generating the system assigned managed identities for this cluster in the node pool. In the sense, we are declaring the cluster nodes, and then they are like agent pools, and the versions of the image is something like standard underscore D2S underscore v3 version. And then the node count is nothing but the number of nodes that you want in a cluster. Then we have a Linux profile. So here we are using the, since the the all AKS clusters are hosted on the by default hosted on the Linux, so we need to have a the default login profile, that is username and the SSH key. So SSH key is generated dynamically by using the another SSH file. I'm going to show you that as well. So that SSH key is been referenced here. Then we have a network profile. So network profile, we are using the plugin for this AKS cluster is KubeNet, and the load balancer SKU is standard, because here I'm exposing the service of this Kubernetes cluster via over the AWS load balancer, sorry, with the on the Azure load balancer or Azure application load balancer. Okay, then we have output file. So this output file actually output certain the property names of the AKS cluster, which includes resource group, Kubernetes cluster name, client certificate, client key certificate, CA certificate, cluster password and cluster names, host data, kubeconfig file. Okay, so this output file is meant to reuse. If you want to use Kubernetes provider and deploy the application, you can reuse it. That's the purpose. We have output.terraform file which could be reused again ahead. But in my case, I'm not using Kubernetes provider, but I'm using a the one of the, say, like a workaround or an intelligent way to actually deploy an application. I'm going to explain like why it is intelligent. Stay tuned ahead as well. So now let me go to the provider. In the provider, this is basically declares the Terraform provider required for the infrastructure. That is, the required version of the Terraform is greater than version 1, which is actually takes the latest one. Then we have a required provider. So here we are using Azure APS, because we are using this Azure APS at SSH. Then we are having the Azure RM, which is actually the Terraform provider for Azure, right? And then we have a random provider as well. Then we have a time provider. We are using this one. And this is the backend configuration. As I said, we have our backend hosted on the Terraform cloud, or nothing but app.terraform.io. This is the site. So you can create a subscription for app.terraform.io, and then you can create an organization like this. So I have an organization called cloudquicklabs, which is equivalent to my channel name. So there I have actually created a workspace, and that workspace is been referenced here. So in the remote backend, we have the app.terraform.io. Then this is the organizations, and this is the workspace. So I'm going to take you to there actually. So now let me explain what are the configuration that we maintain on the Terraform cloud for the creating the the Azure AKS cluster. So here I created a workspace with the name like Azure AKS Labs. So if I go to the Azure AKS Labs workspace here, so this is the Azure AKS Labs which I created. To create, how to create, so you might have a questions, how did I create? So if you go back to the organizations underneath the workspace, there is a button called create a workspace. So there is an option to create a workspace. Click on this one, and then here you're going to choose the API driven one. So here you're going to provide the data, basically you're going to provide the name of your workspace name, and then give the project name, give the description, click on the create workspace. Your workspace will be created like me, right? So I'm going to go to the Azure AKS Labs. Okay, so this is how my Azure AKS Labs is being created. So underneath this one, so if I go to the variables, so now here I have created a further variable, say like Azure RM client, Azure RM secret, so Azure RM subscription ID, and the tenant ID. So basically these are all the, so I'm using AD SPN or Entra ID SPN to authenticate to the Azure subscription. So to show that, I'm going to go to the Azure AD or Entra ID. So you can, right now the Azure AD is been rebranded as Microsoft Entra ID. So you need to call it as a Entra ID now. So if you go to the Entra ID, so here I have created an SPN or an app registration. So this is the SPN I created. So in this SPN, so I have the data like what is the if I go to ORU, so here we have a tenant ID, and also I have a subscription ID. Those data are being kept here, the subscription ID and tenant ID. And then I also created that application's secret. So if I go to the applications, So basically app registrations, click on this one. So here click on this, and then you have a certificate and secrets. So in this one I have created these my secret value and the secret IDs have been kept here. So those values are being configured here. So make sure that you keep the key value exactly equivalent to whatever I'm showing you here, and it should have 4 keys, and the name of these key should be exactly like this. If you try to do here and there even small letter, it will not work. And these are all sensitive information, so make it like a tag it as a sensitive. So to do that, click on this variable. You can go to the environment, right? So provide those 4 keys here and provide the values here, and make sure that you mark it like a sensitive and add variables. So eventually, so likewise I added the workspace environmental variables like this. All right, so all the categories are environmental variables. So like this I have created, and this SPN is being given as the level elevated permissions on the subscription. That's the reason this SPN has an access on the my subscription. Okay, that's the reason it is able to create a AKS cluster for me. All right, so that is what I did on the the Terraform cloud. Okay, all right, so that is where the let me come back to the original point. Okay, so we were walking through this code, and then I jumped to the Terraform cloud, and I showed you like how to create a workspace, how to configure it so that it works as expected. Now let's go down the file. So here also I'm declaring the provider for Azure RM, where future you need to declare something like this. Let's go to the ssh.cf file. So this is ssh.tf file. As I said, this is the file which is actually creating the the API keys, that is SSH API key required to spin up the AKS cluster, right? So here we are again reusing the random pet to generate the SSH key name. Then here we are using the Azure API resource actions. So this is the Microsoft Compute. So basically, this we are using the API underscore resource API actions and generating the public key basically, right? And this is the resource ID, yeah. And then the action is equal to generate the key pair, and the method is post. So response export value equal to this one. So basically, this is the file which actually creates a SSH public key required for to create an AKS cluster. Okay. Likewise, if I go to the last variable, that is variables. Okay. So the variables are something we are using like var, right? So if I go across the file, we are using something like var. In the sense, if you go across the file, so we have a 4 variables being used, and also few variables are also used in the SSH file, right? All those variables values are declared here. In the sense, we are declaring that we have a variable called resource group location. By default, there is a value called US East, so East US basically. And then we have the group prefix which is standing with RG. Similarly, node count, so I'm keeping the node count equal to value equal to 2, right? And then the MSI ID, username. So these are all the variables which we declared. Okay, so with that, we are done with the how did the AKS cluster definition happen in the Terraform along with the Terraform cloud configurations. Now I will quickly walk you through the AKS store quick start.yaml. Anyways, these files will be shared in videos description. You can find it. Now I'm just quickly walk you through like what is this specification file or manifest file is deploying on the AKS cluster. So one is, it also has a multiple application deployment. So one is we are deploying the RabbitMQ configurations. You can go through this more details. This is very complex one, so it will take time to go through, right? So likewise, we are having multiple deployment that so this file defines a deployment. After the deployment, this is deployment. When you say deployment, nothing but you're actually deploying an application or creating a pod in the Azure AKS cluster, right? And then in front of that pod, you are actually, or basically you are grouping the number of pods and creating a services in front of it, and that is called as a Kubernetes service. And these are Kubernetes services are being defined here. So there are multiple the multiple pods are being deployed on this EKS cluster with these definitions. Likewise, in front of those pods, uniquely we have a multiple services as well. And then finally, if you go down bottom line, which is very important for this demo, so that is, I'm creating a service name called storefront, and that storefront is been exposed over port number 80, right? And it has a type equal to load balancer. So if I go to this one, so basically remember that so this is Azure load balancer is being consumed here to access the services. All right, so that is all about the manifest file. You can use this file, reuse this file, because anyways I'm giving these reference files in this video's description. Go to the video's description, find there is a reference of GitHub link. You can click on that, it will take you to this file and you can explore from there. So let's go to the Azure AKS workflow. So this is, now we are in the CI/CD part. So what is the CI/CD? That is continuous integration and continuous deployment, right? So continuous integration, continuous deployment is nothing but, it's actually compiles these code and runs against the targeted hosting environment, that is against the Azure, and deploys the AKS cluster. Post AKS cluster is deployed, then on top of this AKS cluster we are deploying our application. Okay, that is actually a full stack, in the sense, this is purely full stack. All right, so purely managing the full stack with using CI/CD, this is what we can do, right? So here we have the images, nothing but, our application wrapper, right? So you have an application written in the Java file, written in the Python, programming language. You can wrap that application as a Docker image, and that Docker image is been referenced here in this manifest file or specification file. Okay, all right, so that is basically, you can also again write your source code here itself. Okay, so everything in a single repository. All right, so that is just a brief input from my side, which I like to have in a single repository. All right, so I will go to the this is my workflow name. So this workflow will be dispatched manually, that is workflow dispatch, right? In the sense, you can only trigger this by manually. Then we have a permissions for ID token, that is read and write, because I'm using here OIDC token as well. If you want to understand what is the OIDC token, OIDC authentication in Azure, you can watch my another dedicated video where I have made on this one, on this topic. So here we have a job called AKS cluster deployment. In the sense, it creates a cluster plus deploys an application. So it runs on a Ubuntu latest, which is a default GitHub runner. And then we have default definitions, that is run while it is running, it should use a bash. And the working directory is AKS. You see AKS, that is where I have kept all the files required for AKS cluster. So first one, we have a checkout option. Then we are actually using the OIDC authentication to connect to or to log into the AG subscription, that is my Azure subscription, with using AG CLI login, right? And then we have a Terraform setup, that is basically Terraform setup is nothing but, this is what actually interacts with the TFC, right? So here we are using the CLI configurations, and with using that, it will have a connections back to the Terraform cloud. And then naturally we are actually compiling the Terraform init, Terraform validate, Terraform plan, right? And then we have a Terraform status as well. So basically, once you run the Terraform plan, maybe there could be potentially error, so you are checking the error. If there are no error, then you are going ahead and doing the Terraform apply, which actually compiles all these files and tries to spin up the infrastructure against the Azure, right? Then I'm just putting the Terraform output so that I can show you the output actually. And then final, this is the deploy an application. Okay, this is something I thought that I innovated. Okay, so basically, why don't we can do like this? Okay, instead of going ahead and using the the Kubernetes provider, yeah, that is the best method, but that eventually brings a lots of complexity and very difficult to handle, I can say. But if you have a very simple enterprise grade applications, you can still go with this option. It will work. Why it will work, let me tell you, right? So here we are using manifest file, and we are using this manifest file in the sense, this file itself is infrastructure as a code. In the sense, the definition that you are written here is acting itself is it is acting as a version control. In the sense, you have a definition of your an application, say version 1, and that you are deployed into the AKS cluster with using kubectl. Then you are creating version 2 with some modification. If you deploy it on the AKS cluster, the AKS cluster the kubectl automatically maintains the versions from the backend. In a sense, in cluster, it actually maintains the application versioning. So in that case, we don't really need to worry about deployment of an application on the Kubernetes with using again with using the infrastructure as code, while you can directly jump for using the kubectl command. Okay, that's the reason I was using this option. So here what I did is, I'm just loading the credentials of the AKS cluster by pointing to my cluster name and my resource group name, which eventually loads .kube config file. Yeah, and then so I'm using the kubectl command, because as you know that the GitHub Actions is preloaded with the kubectl inside kubectl utility. So we are using the kubectl utility. Kubectl utility, under the hood, it will use the kube config configurations to authenticate to the AKS cluster and try to deploy this application. All right. So once the application is deployed, I'm just sleeping for 40 seconds because the application deployment will take some certain times. Right. And then I'm actually running the kubectl get service to get the the endpoint of the cluster. Okay. And then finally, I'm just removing the kube config folder so that we are securing actually. All right. All right, so with this option, I have walked you through the complete code base of AKS cluster creation with using Terraform. and then deploying an application on that AKS cluster with using kubectl commandlets, which is automated. All right, so what I will do is, we're going to take you to the GitHub Actions. So this is my GitHub Actions. This is my repository which I have walked you through now. So there is a one workflow with a name like create AKS with Terraform, right? So we're gonna run this code right now by pointing to the main branch. Remember that the AKS cluster creation will take like nearby 15 to maybe nearby 10 minutes. So to save the time, which I have already deployed an AKS cluster. So if I go back to the RGs, if you go to the resource groups, so we have a resource group. In the sense, you see that our AKS cluster is up and running fine. But this is just to make sure that the code is working fine. Okay, that's the reason I'm just running this code. So this is like a pure demo of end to end actually. So here you see, right, currently we have a AZ login which is using OIDC Connect, and the login was successful. And then we are actually doing a Terraform setup, setup, which is actually also done. So basically this is nothing but it is pointing to the app.terraform.io, nothing but here. You can also see the runs here. So you can also see the runs happening here. You see, so it is like a end to end. That's what I said initially, that the compilation will happen from the Terraform cloud, and the state will also be configured there. All right. So it looks like it has done the job. You see there is a init Terraform init happened, which is successfully happened, and we have a Terraform validate also happened actually. And then we have the Terraform plan. So Terraform plan says that so basically if I go here, so there is no change because the required infrastructure is already up and running fine. Yeah. And then then after that we are checking the Terraform plan status, which is actually there is no error. That's the reason it's skipped off. And then we are actually running the Terraform apply. That is nothing but run Terraform apply -auto approve, right? Auto -approve. And then we see that these are all the infrastructure are being created, right? All right. And then after that we have a task called Terraform output. So we are running the command called Terraform output. So you can see the commands which you were run in the across each task by expanding this one. Okay, this is the blue mark is nothing but that is the command it executed in that task underneath the job. So this is the task, that is Terraform output is a task. So it has output. You see that it has given all the outputs, that is host name, certificate name, blah 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 and all right. And then we have a application deploy, which I was explaining, like yes, this is like a something like innovative that you can try to use it. Okay, this is very simple, it's not complex, right? And it does not need to maintain you a very complex Kubernetes provider, right? You can eventually manage, in the sense you are actually managing your application deployment as a version controlled, plus you are reducing the complexity, which I make a loud nice. Maybe again I'm open to find out any problems here. So maybe, right? So this could be another workaround basically, which will eases the some people's job actually, right? So here in the deploy application, so we are actually running the agcli command, updating the kube config file. Then I'm running the kubectl apply, which actually deploys these deployments. You see that it deploys an application RabbitMQ. It creates a kube config map, that is config map, right? So it's creating the config map. It is creating a service called RabbitMQ. Then it is also deploying an application called order services, then creating a order services as well. Then it as, so basically there are 3 deployments if I'm not wrong. So there are 4 deployments, that is production service, storefront, and then we have a respect. In the sense we have a 1 deployment and we have a service for that. Yeah. So here I wanted to get the endpoint of the app store service, right? So here we have a deployment called app store, and that didn't change because it is already deployed. And then so that service is being exposed over an external IP address or public IP address. We can now go ahead and access this application from the internet. Okay, so till now I have completely walked you through from scratch to end to end configurations, and then we showed you that the infrastructure is deployed here. So if I go here, the complete infrastructure is deployed. And if I take you to the, before I show you the application working, let me walk you through the infrastructure from the Azure subscription. So this is my Azure subscription. When we create a Azure AKS cluster, it does creates a managed container group, something like this, and this group is managed, so you cannot modify here. So it has created these many resources. You see public IP address, scale set, NSG, we have a route table, then we have a load balancers. As I said, we have a load balancers. All right, and then we have a network watcher being created because we are creating the VM scale set. And then if I go to the RG, that is refined swine, that is my RG. This is the RG which we created, and this is the place where actually Kubernetes service, that is AKS service, will come and sit. If I open this AKS cluster, currently it is in healthy and it is in working stage. You see that is running stage. And here are the lot of options that you can explore from your side. Meantime, let me quickly walk you through this. So basically, the most interesting are the Kubernetes resources. If you go to the click on the resources, it does list all those namespaces deployed on this Kubernetes cluster, which includes node, kube, and then we have this one, blah blah. This is a default. So if I open the default, so you're gonna see all those further details could be seen here. You can drill down and explore, right? So likewise, we go to the workloads. So we have the workloads, that is deployments, pods, replication, stateful set, daemon sets, jobs, cron jobs, everything will be listed. This is very awesome that the AKS provides a good visibility here, right? So it shows you what we deployed, right? So I said we deployed 4 applications. So it has a storefront, RabbitMQ, product service, order service, right? And rest all are like default one. All right. So all these applications are deployed in a namespace, default namespace. Then if I go to the pods, so we should see our pods as well. So here you go, right? So if you can sort it by default, so underneath the default you have order, RabbitMQ, storage, right? So all these parts are nothing but your applications are running as a container application now. Now let's go to the replica set. So let me check if we have a replica set. I don't think so. So we have a replica set as well. So my application also has a replica set. So what is a replica set? It's in the sense, so you have an example pod that is been spinning across the nodes. In the sense, in this one we have a 2 nodes. So across the nodes, we will have these applications deployed. All right. Then let's go to stateful state. We don't have anything underneath the daemon set. We don't have anything. So we have a daemon set as well here. So there are the default daemon set that is coming from the cluster side. Then we have a jobs. If I go to the jobs, there is no jobs. There is no console job as well. Now let's go to the service and ingress. So here we can see the services being created on this cluster, which is very good view. So this is the service which I explored in the GitHub, right? So this is the service I did the read, and this is what the external IP address. So if I go ahead and compare, this is the application IP address of this service. So likewise, we have the other services which are not exposed on the public, on the load balancer basically. So this is the load balancer IP address. In front of backward, so backward we have a Kubernetes service called storefront. All right. And then so this is all about. So then you can also explore the ingress. So if any ingress are being configured on the clusters, will be visible here. So there are no ingress as of now. So we have a storage configurations as well. So you can see that storage configurations, persistence value, storage class value will be shown here. Then we have configurations in the sense, like for example, say we have created a configuration, in the sense cluster configurations or config maps, right? So our config maps are something like, for example, say RabbitMQ enabled plugin. So those are config maps have been configured. So if you go to secrets, so these are all the secrets will also be created. So all these secrets are belongs to the default one. And then we have a custom resources. So if you have created any custom resources, will be listed here as well. Okay. Then the events and the run commands could be explored. In the sense, this looks to be awesome. Basically, it has very good visibility across the clusters. And the one more thing which I would like to show you is the node pools. In the sense, how many node pools do we have basically, right? So if I I have created only one node pools with the two targeted nodes. If I open this one, go to the nodes. So we have 2 nodes been running here, right? And that is what we have declared in the cluster definitions, and that's all. That basically that's all about the complete end-to-end walkthrough of the the Kubernetes cluster. Okay, so rest all configuration like cluster configurations, networking, backup, GitOps could be explored further. Right now, time has come to access the service. So what I do is I'm gonna go to the Kubernetes resources. Let's go to the services and ingress, right? And then I'm going to click on the public IP address. Okay, so here is the public IP address. If I click on this one, our application is up and running fine. Okay, so this is an example application which we deployed. It is just like a store application, and it has like a blah blah things are happening here. So if I can click on this one, so looks like it is working. Yeah, so you can also increase this one basically, just like this. Yeah, so basically what I mean is, so we have successfully shown you the end-to-end scenario of the how to create an AKS cluster in the Azure, how to deploy an application on the same created the AKS cluster with using manifest file or specification file with using GitHub Actions. All right. So with that note, I have shown you the thing, things need to be shown in this video. Finally, I can't request please to subscribe my channel. That would really encourage me a lot. So with that note, thank you, thanks a lot, and see you in the next video.